Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to solve GATE 2024 problems for the subject Signals and Systems for Instrumentation discipline. The topics which I have taken is common for electrical, electronics and instrumentation. So all those branch candidates can watch this video completely. Let me start solving the problem one by one. So this is the first problem taken from the instrumentation discipline. So let me start solving the problem. So here, first I will read out the problem. Consider a discrete time sequence. One sequence is given, x of n equal to 0.2 power n for 0 to 7, 0 otherwise. The region of convergence of x of n. So we need to find the region of convergence for the given sequence. Okay, so I will write the sequence. So this is the given sequence, x of n equal to 0.2 power n for 0 to 7. So 0 to 7 is a finite sequence. 0 otherwise. So this is the given sequence. We need to find the ROC, region of convergence. Okay. So here we know x of n equal to 0.2 power 0, 0.2 power 1, 0.2 power 2 up to 0.2 power 7 is the given sequence. Okay. Given sequence. Now we need to find the x of z. So x of z equal to 0.2 power 0 is 1. So 1 plus 0.2 z power minus 1 plus 0.2 square z power minus 2 up to 0.2 power 7 z power minus 7. So this is the z transform of the given sequence. So by the z transform, we can find the ROC, region of convergence. So see here, this is the z power minus 1, z power minus 2 up to z power minus 7. So we have the negative powers. So we can conclude that ROC includes all values of z. Since this is a finite sequence, all values of z except z equal to 0. Except z equal to 0. So if we substitute, it will not converge. It will become infinity. Okay, 0.2 by z, if we put z equal to 0 means it will not converge. So all values of z except z equal to 0 is the region of convergence. This is the answer for the given problem. So see the options. So option C is the correct one. Option C is the correct one for this problem. All values of z except z equal to 0. So let me move to the next problem. So this is one of the simplest problem given in instrumentation engineering. The Nyquist sampling frequency for x of t equal to 10 sine square 200 pi t is dash hertz, rounded off to nearest integer. Okay. So here the given sequence, given signal is x of t equal to 10 sine square. First we will simplify the signal. Then we will find the Nyquist sampling rate. So we know sine square theta equal to 1 minus cos 2 theta by 2. So by using this formulation, let me simplify x of t. So 10 into 1 minus cos 2 into 200 pi t by 2. So it will get cancelled. 5. So it will become 5 minus 5 cos 400 pi t. 400 pi t is the frequency. Okay. So here, this is the given signal, simplified x of t. So from this, we have to find the Nyquist sampling frequency. Nyquist sampling frequency is nothing but Fn equal to 2 F max, maximum frequency component. So by observing the input signal x of t, the first is the DC term. So there is no frequency. So only second component is the So 400 pi is the only frequency, that is the maximum frequency. Okay. So here we will put omega equal to 400 pi. So we know 2 pi f is equal to omega. 2 pi f equal to 400 pi. So this pi will get cancelled. 2 and 400, that will get cancelled. So here only one term we are having. So f equal to f max equal to 200 hertz. Okay. So let me find the Nyquist sampling frequency Fn, that is equal to 2 f max, which is equal to 2 into 200, that is 400 hertz. So here for this problem, 400 hertz is the answer. So this is the 400 hertz. Okay, 400 hertz. So this is one of the simplest problem. This is NAT type question, numerical answer type question. There is no negative marking for NAT type question for the GATE exam. Okay. Let me move to the next problem. Laplace transform of a signal x of t, x of s is given. Let u of t be the unit step function. Choose the signal x of t from the following options. If the region of convergence is real part of s is between -7 and -6. So region of convergence is given, x of s is given. We need to find the input signal x of t by using inverse Laplace transform, by taking inverse Laplace transform of x of s. Okay. So first, let me simplify x of s. So here, x of s equal to 1 by s square plus 13s plus 42. It is simplified as, when we take the factors, 1 by s plus 6 into s plus 7. Okay. Now, by partial expansion method, we can simplify that as a by s plus 6 plus b by, taking a and b as partial coefficients. Okay. So let me simplify. 1 equal to a into s plus 7 plus b into s plus 6. So when we put s equal to -7, this term will get cancelled, and this is b equal to -1. So when we put s equal to -6, a equal to 1. So by substituting b and a in the x of s, this x of s will become x of s equal to 1 by s plus 6 minus 1 by s plus 7. Now we need to find the inverse Laplace transform of x of s. So before taking the inverse Laplace transform of x of s, so we need to consider the given region of convergence. See here, the region of convergence for the signal is given. So we need to consider this before finding the input signal. Okay. So whether it is u of t or u of minus t, we have to decide from the given region of convergence. Now, region of convergence ROC is given as -7. Real part of s is between -7 and -6. So let me draw the s plane. So this is sigma, real part of s, and this is j omega, imaginary part of s. Okay. So see here. Now we are having the poles -6 and -7. So this is -6. I am taking this as -6 and this as -7. Now ROC is between the -6, between the poles -6 and -7. So the region is like this. It is lying between -6 and -7. So this is the ROC. Okay. This is the ROC. ROC is lying between -6 and -7. So now, considering this, when we consider the pole -6, it is a left-sided signal. Okay. It is a left-sided signal. So we have to consider that a left-sided signal. We know u of t is the step function, step signal, that is a positive-sided signal, right-sided signal. U of minus t is the left-sided signal. So when we consider the pole minus 6, we have to consider the input signal as u of minus t. When we consider the minus 7, it is a right-sided sequence, right-sided signal. So we have to consider that input signal as u of t. Okay, so this you have to remind that. Okay, so we have to consider this as the consideration to find the input signal, to find the inverse Laplace transform of x of s. Okay, now L inverse of x of s equal to x of t. So before finding the inverse Laplace transform, I am going to tell you one thing. Inverse Laplace transform of e power at into u of t for the positive, for the right-sided step function, e power at u of t is, we know, 1 by s minus a. Okay. Same Laplace transform of e power at into u of minus t is minus 1 by s minus a. So we have to consider this to find the inverse Laplace transform of x of s. Okay. Now for the pole minus 6, we have to consider the left-sided step signal, that is u of minus t. Now 1 by s plus 6 has to be simplified like minus 1 by s minus a. Okay. So I am going to simplify like that. So x of t equal to L inverse of 1 by s plus 6 minus L inverse of 1 by s plus some. Okay. So for the pole minus 6, we have to consider u of minus t. So for that, I am going to simplify like, I am going to multiply and divide by minus 1. Okay. So L inverse of minus 1 by minus of s plus 6. Okay. Minus L inverse 1 by s plus 7. Now this is u of minus t. And this is, we are having negative signal. Laplace transform of e power at into u of minus t is minus. So in the formulation itself, we are having one minus. Another minus is in the denominator. So minus of e power minus 60. And here for the pole minus 7, only right-sided unit step signal minus e power minus 70. So this is the input signal. This is the input signal x of t. Minus e power minus 60 u of minus t minus e power minus 70 u of t. Okay. So see the options, observe the options. What is the option? Which option is the correct one? Option B is the correct. Minus e power minus 60 into u of minus t minus e power minus 70 into u of t. Okay. So before going to find the inverse Laplace transform, we have to consider the region of convergence to find the input signals. So here we solved 3 problems. I have taken these 3 problems from the instrumentation discipline. This is Mani's Gate Tech Vision. This is the channel for engineering lectures. You can subscribe to my channel. You can view the lecture series. Thank you very much for watching the video. This is my mail ID. You can ask any queries. You can mail to me. Thank you.